Imagine standing at an airport in the near future. The runway looks the same. The control tower stands tall, passengers line up at the gate, but something feels completely different. There is no roar of jet engines shaking the terminal windows, no burning smell of aviation fuel drifting through the air, and no thick, white contrails painting lines across the sky. Instead, an aircraft begins to move silently, almost like a giant glider, rolling toward the runway with a soft electric hum. The pilot pushes the throttle forward, and the plane accelerates smoothly, lifting into the sky without the explosive noise we have associated with flight for over a century. This is not science fiction. This is the next revolution in aviation. Electric and hydrogen-powered airlines, and it may redefine how humanity connects across the planet forever. For decades, aviation has been one of the greatest achievements of human engineering, shrinking the world and allowing people, cultures, and economies to connect in ways never before possible. Yet it has also remained one of the hardest industries to because modern jet aircraft rely heavily on energy-dense fossil fuels. Today, aviation produces roughly 2 to 3% of global carbon emissions. And while that number may sound small, the growth of global travel means emissions could triple by 2050 if nothing changes. Governments, scientists, and aircraft manufacturers understand this challenge, and instead of abandoning air travel, they are redesigning it entirely. The future aircraft will not simply burn fuel more efficiently. They will not burn fuel at all. Electric propulsion and hydrogen energy are emerging as the two most promising technologies that could make aviation clean, quiet, and sustainable. Electric aircraft work in a way surprisingly similar to electric cars, using battery-powered motors to spin propellers or fans. But aviation demands far more energy than a road vehicle, because lifting a heavy machine into the air requires enormous power density. Engineers are solving this through lightweight composite materials, distributed propulsion systems, and ultra-efficient aerodynamic designs, where multiple small electric fans replace giant engines, dramatically improving efficiency and safety. Companies like Aviation, Heart Aerospace, and Magnix are already flight testing electric regional aircraft capable of carrying 9 to 30 passengers over short distances, meaning your future domestic flights between nearby cities may feel more like boarding a train in the sky than a traditional jet. These planes will cost airlines far less to operate because electricity is cheaper than jet fuel, and electric motors contain far fewer moving parts than turbine engines, reducing maintenance costs dramatically. Lower operating costs mean cheaper tickets, opening air travel to millions more people while also reducing environmental damage. But electric aviation alone cannot handle long-haul flights across oceans, because batteries still store less energy per kilogram than liquid fuel, and this is where hydrogen enters the story. Hydrogen is the most abundant element in the universe, and when used as an energy source, it produces only water vapor as a byproduct, instead of combustion engines. Hydrogen aircraft can use fuel cells to generate electricity or burn hydrogen directly in modified turbine engines. Airbus has already revealed concept aircraft under the ZRO program, aiming for commercial hydrogen flights by the 2030s, featuring futuristic blended wing bodies designed to store cryogenic liquid hydrogen in insulated tanks inside the fuselage. Airports themselves will evolve into energy hubs where renewable electricity from solar and wind powers electrolysis plants producing green hydrogen on-site, turning airports into zero-emission ecosystems rather than pollution centers. The passenger experience will also change dramatically because electric motors produce far less vibration and noise than jet engines, allowing aircraft cabins to be quieter than ever before, reducing fatigue and making flights more comfortable. Short regional flights may depart more frequently because smaller electric planes will allow point-to-point travel instead of routing everyone through massive hubs, meaning you could fly directly between smaller cities without connections. This transformation may be as significant as the shift from propeller aircraft to jets in the 1950s. Airlines themselves are preparing for this transition because sustainability is becoming not just an environmental concern but an economic necessity. Fuel represents one of the largest operating expenses for airlines, and volatile oil prices create financial instability across the industry. Electric and hydrogen aircraft promise predictable energy costs, shielding airlines from fuel market fluctuations and making ticket pricing more stable for passengers. Governments worldwide are introducing carbon taxes and emissions regulations that will increasingly penalize traditional jet operations, pushing airlines toward cleaner technologies, whether they like it or not. Investors are pouring billions into aviation startups because whoever dominates zero-emission flight will control the next century of air transportation. The shift will not happen overnight. Large wide-body jets carrying hundreds of passengers across continents will likely remain powered by sustainable aviation fuels for some time, acting as a bridge between old and new technology. However, history shows aviation evolves in phases. First, then regional adoption, then global transformation, and electric and hydrogen propulsion has already passed the experimental stage. Training for pilots and engineers will adapt as well, because managing electric power systems differs greatly from managing fuel combustion engines, creating entirely new aviation careers. Even airport design will change with charging infrastructure, hydrogen storage facilities, and redesigned ground operations, eliminating fuel trucks and reducing turnaround times. The environmental benefits extend beyond carbon emissions, because quieter aircraft could allow airports to operate longer hours without disturbing nearby communities, increasing capacity without building new airports. Imagine living near an airport yet barely hearing aircraft overhead. That is the promise of electric propulsion. Cargo operations may adopt electric aircraft even faster than passenger airlines, because short-haul freight routes are ideal for battery-powered planes, meaning your online shopping deliveries could soon arrive via zero-emission aircraft. This transformation is not just technological. It is cultural. For over 100 years, the sound of jet engines symbolized power and speed. But future generations may associate flight with silence and sustainability instead. Aviation began with fragile wood and fabric machines barely lifting off the ground, evolved into supersonic jets crossing oceans in hours, and now stands at the edge of another revolution. One not focused on speed alone, but on responsibility to the planet. The question is no longer whether electric and hydrogen aircraft will exist, but how quickly they will replace traditional jets. The airlines that adapt early will define the new era of aviation, while those that resist risk becoming relics of a fossil fuel past. Humanity has always looked to the sky as a symbol of progress, and now the sky itself demands a cleaner future. The next time you book a flight, the aircraft waiting at the gate may not burn fuel at all. It may run on electrons, or the most abundant element in the universe, carrying you across the world while leaving almost nothing behind except a faint trail of water vapor and the quiet promise of a sustainable age of flight. As the transition accelerates, the aviation industry will undergo its most dramatic transformation since the invention of the jet engine, reshaping airline competition, airport infrastructure, and even global travel behavior. Airlines that once competed purely on routes and service quality will now compete on efficiency of energy use, battery technology partnerships, and hydrogen supply chains, turning energy providers into strategic aviation allies. Major aircraft manufacturers are redesigning planes from the ground up because electric propulsion frees engineers from the limitations of placing engines under wings. Motors can be embedded along the wingspan to create distributed thrust, reducing drag and enabling shorter takeoffs from smaller runways. This means regions previously inaccessible to aviation could suddenly become connected, boosting tourism and economic development in remote areas. Hydrogen aircraft introduce another revolutionary possibility: large blended wing body designs where passengers sit inside a wide triangular structure rather than a narrow tube, improving aerodynamics and allowing panoramic cabin layouts unlike anything seen before. Flights may feel more like traveling inside a modern high-speed train or lounge, rather than a pressurized cylinder. Safety improvements will also be significant because electric systems provide redundancy. Multiple motors can compensate if one fails, and hydrogen fuel cells generate power continuously, without explosive combustion characteristics associated with kerosene. Critics often question whether producing hydrogen or electricity simply shifts emissions elsewhere, but the aviation roadmap integrates renewable energy generation directly into airport operations, meaning aircraft energy can come from solar farms, wind turbines, or hydroelectric power, making the entire life cycle cleaner than any jet fuel alternative. Ticket booking systems may even display environmental impact scores alongside price and duration, allowing passengers to choose flights based on carbon footprint, creating a new form of competition where sustainability becomes a selling point. Business travel patterns could change as corporations prioritize zero-emission transport for climate commitments, giving electric airlines immediate market demand. Maintenance hangars will look different too, filled with diagnostic computers and battery modules rather than oil-stained turbine parts. And turnaround times could drop dramatically because charging and system checks are faster than fueling and engine inspections. Eventually, autonomous flight technologies may combine with electric propulsion to create highly efficient regional air mobility, networks operating almost like aerial public transport, connecting towns every hour with minimal operating cost. The environmental impact on cities near airports will be transformative, because reduced noise could allow urban airports to expand operations without community opposition, increasing connectivity while preserving quality of life. Over time, younger generations may grow up never experiencing the thunderous takeoff of a classic jet. Just as many today never experienced propeller-driven transcontinental flights, the psychological perception of flying may shift from something industrial to something almost serene. However, challenges remain: battery weight, hydrogen storage, certification regulations, and global infrastructure standardization all require international cooperation. Yet aviation historically thrives on global standards, making it one of the few industries capable of coordinated worldwide transformation. Governments see zero-emission aviation as essential for meeting climate targets, and subsidies, similar to those that accelerated electric cars, are beginning to support aircraft development. Once the first profitable electric regional airline proves its economic advantage, adoption could accelerate rapidly because airlines operate on thin margins and quickly follow cost savings. The aviation revolution will not eliminate pilots, airports, or airlines. It will redefine them, just as jet engines once did. In the 20th century, humanity conquered distance. In the 21st century, it must conquer consequence. Electric and hydrogen aircraft represent more than new machines. They represent a new philosophy of transportation, where speed no longer conflicts with sustainability. The sky that once symbolized industrial power may soon symbolize environmental harmony. One day, a child looking out an airplane window may see clear blue skies free from exhaust trails and learn that flight no longer harms the world below. When that moment arrives, aviation will not only connect continents, but also reconcile progress with responsibility. The journey from burning fossil fuels to flying on clean energy will stand as one of humanity's greatest engineering achievements, proving that innovation can preserve the freedoms we love while protecting the planet we depend on. The future airport gate will look ordinary, the boarding pass familiar, the destination exciting, yet the aircraft itself will embody a century of technological courage and a promise kept to future generations. And when the engines start, you may barely hear them at all. Just a gentle hum as the plane lifts into the sky, carrying humanity forward into an era where travel leaves memories, not emissions. The true dawn of sustainable aviation and the beginning of a new age of flight.